Okay, this is our chemistry final review. I'm going to go through each problem. There's 143. In doing so, you should have a periodic table with you and maybe the polyatomic sheet. And some of the things I'll explain mathematically and show you, others I'll just give you the answers. But to begin with, when we start with number 1, on the matching, the smallest particle of an element that retains the properties of that element, the answer is C, and that would be an atom. Number 2, a positively charged subatomic particle. I tend to do it like this. Number 2, I write P with a plus. That would give us a proton. Then we have, for number 3, a negatively charged subatomic particle. That's our electron, so the answer for that is going to be D. Subatomic particle with no charge, and with no charge I use neutron, and the letter for that's going to be E. And the central part of the atom that contains both the protons and the neutrons, and that's to the inside, and that is going to be B, and that is what we call the nucleus of the atom, and it's the centermost of the atom. Going to number 6. In number 6, horizontal row. So for number 6, it's a horizontal row on the periodic table. I think of writing a sentence, going across the sentence, and you end with a period. It is called a period as you go across, and that is H. A vertical for number 7 is I, and that would be a group. So as you go up and down, those are groups. They're also called families. As you go up and down, they're given different names, like alkali, metal, etc. Number 8, the type of element characterized by the presence of D subshells. Here's my little quick picture here. This is my S's. We know this to be in configurations P, and here are my D's, and that's what's being asked in number 8. And those are transitional metals that are found there. So transitional metals. And that answer would be E. Number 9, type of ion formed by group 2 elements, and those are the ones that you find here. And they're going to say it's a type of ion, and because it's an ion, and we're on number 9 right now, an ion is a charged atom. So it's either going to be a positive or a negative, and in this case, it's going to be a positive in group 2, losing 2 electrons. It is +2, and it's going to be a cation. And therefore, number 9 is going to be G. When I look at number 10, the subatomic particle that is transferred to form a positive or negative ion, what we get with that for number 10, you're giving from one atom to another, you're transferring electrons. Yep. So we're transferring electrons from one to another. So for 10, the answer is J. Number 11, the ability of an atom to attract. Some people think electron affinity. That's fine. We also have electronegativity, bringing electrons to into an atom when it's in a compound. That's its electronegativity. And different compounds have different electronegativities, and that will help me to decide whether it's an ionic or covalent compound that exists. So the answer for number 11, we're looking at A. Now 12 is the energy required to remove an electron. We've talked about that before. That is, you want to take it from an atom, usually, which is neutral, no charge, and you want to remove an electron from it. It's going to cost energy to do it, and the energy required is what it's going to make this atom into an ion. So we call it ionization energy. We can have first, second, third ionization energies, and that would be taking the first electron away, the second, the third electron. And they have different degrees of difficulty based on their location on the periodic table. The next thing, going to number 13 now. 13, a theory is a well-proposed explanation. So 13 is simply going to be B. 14, as we go through it, what do we see about using your senses to obtain information? That is what part of the scientific method? That is C. That is going to be making observations using your senses, which is not an example of matter. For number 15, the answer is going to be B. Heat is not matter. 16, all of them are physical properties except, so we have mass As a physical property, color, melting point, but the ability to rust. Rust is a chemical change, not physical. So the answer for that is going to be D. Number 17, I'm on the back of the first page now. Which of the following are considered physical properties of a substance? The answer is going to be all. When you look at color and odor, so that's D. You look at color and odor, melting points, malleable, hardness, those are all physical properties. The state of matter with a definite volume and shape, and takes the shape of its container. Well, that would be a liquid, because if I have a beaker, and it has, say, 15 mils of water in it, and it should be blue, but it's not, so that's all right, because water's blue because it's really clear. You have 15 mils. I can then put it in a graduated cylinder, and it will go 15 mils up the graduated cylinder. So it's changed the shape, but it still is 15 mils. It has a definite volume. So the answer for 18, it's a liquid that would do that. Number 19 is going to be a little different. If this was a solid, if I have a solid container and it's gas particles, and then I put it into another shaped container, totally different or whatever, those gas particles will still fill up the entire shape and spread out. So they occupy the volume and the shape of the container. 19 is a gas, 19 is C. Number 20. We're looking at hetero versus homogeneous. For number 20, we have homogeneous or homogeneous. I think of milk, and thankfully milk is spread evenly throughout consistently, so you don't have cream on the top and the fat and more liquid to the bottom. And that's versus hetero genus. And that one is going to be where it's not the same throughout, but it's different throughout. And an example of that would be soil. The soil, you turn over some soil, you could have a rock there, small little pieces of dirt there, piece of clay here, another rock. It's not evenly spread out. All the others that are given, air in the room. Air in the room, if here's my room, the air here is the same as the air there, the air there. It's all the same percentage. You go down the hall, it's the same thing. Salt water, same kind of deal. Here's a salt water. Yep. Equal concentrations for the most part for that. And then steel it's melted. It's metal that's been melted down, and the composite that makes up it's spread out evenly throughout. So the other one that's not is going to be soil, we talked about here. That is not an even spread for all of it, so the answer is going to be D. Number 21. Number 21, we have a substance that can be separated into two or more substances by chemical change. 21 is going to be D. 22, we're going to look at B for an answer. What is one difference between a mixture and a compound? And that's about separating it. Number 23, I don't like the wording that much. It should say, okay, what the first letter properly written for the chemical symbol should be capitalized. So the first one, they have something like this. Well, that's not right because they're both capitalized. Neither is capitalized on that one. This is correct for iron, and they made that up. So it would be that one. The answer is C for number 23. Number 24. Number 24, oh, that was 24, I'm sorry. Let's see, 22, 23, 22, 21, 22 is B, 23 is B for that reason. 23 is B, they should be capitalized, and 24 dealt with my example there, I apologize. So now I'm on number 25. So when I get to 25, get rid of that. Which of the following is a chemical property? Chemical is going to be the ability to react with oxygen. The key word there for chemical is react. We're going to have some sort of reaction, some sort of change taking place. That's different from just separating it into smaller sizes, for example, or from gas to liquid to solid, things like that. Going further, let's see, we're on number 27 now. A chemical change occurs when a piece of wood, it would be decay. All the others, 26, skip 26, sorry, 26 is A, a physical. For a chemical reaction to occur, you must have chemical properties being changed. 27, wood decaying, is the only chemical change. The others just are altering it, but it's still wood. 28. 28, they give you the number of point. All these zeros. They want to know in scientific notation. It's smaller than 1, so it's times 10. It's going to be a negative. And you want that decimal all the way down where it's 1.5, because we said the range has to be between 1.0 and 9.9 when you move the decimal. 1.5 fits in that range. How many times do we have to make it smaller? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So it's 1.54 times 10 to the negative 10. That would be your answer for 28 for the reasons I mentioned. That is D for your answer. Number 29. 29 is a multiplication using exponents, even if you didn't have a calculator. What you should know is when you multiply using exponents, you add the exponents. So this is what's given to you on the sheet, and you should have your sheet with you as we do it. But you're going to add the exponents. So it's 7 plus negative 7. I'm sorry, it's 10 plus negative 7. That's going to give you 3. So I should have something around 10 to the third. It may be 10 to the fourth, it may be 10 to the second, depending on how these numbers multiply out. And the only one that's even close is going to be C. So without doing any more, just adding the exponents together, that narrowed down to my answer for number 29. Number 30. The closeness of a measurement to its true value is its accuracy. So how close you are to the actual understood value is how accurate it is. So that would be B. 31. We're looking at significant figures. We're looking at two significant figures. Well, in two significant figures, they have this. Excuse that? All right. We have that reading. Well, that's going to show us actually 3 sig figs because here's the decimal. Trailing zeros after a decimal, trailing zeros, these right here, to the right of a decimal count. I have 4 total. I'm sorry, I have 3 total over there. Then I have this. Trap zeros always count, so I have 3 on that one. I have 0.00044. There's only 2 there. And then I have, and that's what we're looking for our answer, so that is our answer. And that one is 3 again, because a trailing 0 to the right of a decimal always counts. So the answer for that one is going to be C, which is this one right here. There's 2 sig figs. Leading zeros never count. All right, so 32. When I look at 32, I have, which one is the most precise? Precision is based on, if you go to a little diagram here, precision is based on how close you are to the same thing over and over again. I could get a shot there with a bow and arrow, another one, another one, another one, another one. I may not be accurate because I'm not hitting here toward the middle, but I am precise. Precision, precise. Because every time I do it, I'm getting similar readings. So which one gives me the closest readings? The 32 is going to be C. It has a range of only 1 between 2, 2.5, and 3. That range total is 1 versus the others which are further away. On 33, you're looking for 3 significant figures. It would be this one. It would be C, which is 7.30 times 10 to the negative 7. You have 3 because that 0 counts. It's a trailer. And if you're not sure, you could do this. Look, I'm going to transfer this into, take it out of scientific notation. Well, once again, that's a trailing 0. That counts because it's to the right of this decimal here. So I have 3 sig figs in that case. I'm going to pause here. You can go to the set part 2. I'll record that in a few minutes, but hopefully you're doing fine with this.